Yeah, so whenever you want, we can start. I guess it's time. So yeah, we'll just want to thank everyone for joining and listening to our presentation. And as Francesco said, we both, Magnus and myself, we are former like Erlang Solutions employees. We work as Erlang consultants for many years, and we are very happy to be back joining for this meetup organized by ESL. And what we are going to be talking about is our backend infrastructure for game analytics. And we will explain, it's going to be a bit of a peek into how an analytics stack looks behind the scenes. And of course, we will focus on explaining how the Erlang VM actually helps us to run the infrastructure. So Magnus and myself, we work with a backend team of 5 team members. And yeah, all of us have a background in the distributed systems and Erlang. And this was our first time working with... Excuse me, can you hear? Yeah. Okay, so let me go to the next slide. Yeah, so this is the agenda for today. We're going to split the presentation in half, and I will talk the first half. Magnus will present the last part. And we will introduce game analytics, explain what we do a little bit, and then give an overview of the backend and divide in different parts. We'll talk about data collection, how we manage our infrastructure, how do the provision and deployment. We'll talk a bit about monitoring and alerting, and then we will introduce other bits of the infrastructure, which are the annotation service and the aggregation analytics service. And Magnus in particular will cover Apache Druid and Elixir in that layer. And also he will cover the latest features we are working on, which are A/B testing and remote configurations, and have some time for questions at the end. So what do we do at Game Analytics? We provide user behavior analytics for video game developers. And you can think about services like Google Analytics, Firebase, Facebook Analytics, and we are similar to those services, but we are focused on just gaming. And what we do is we provide SDKs for the most popular game development frameworks. Think Unity, Unreal Engine, Android, iOS, and so on. We provide, I think, something like 18 of those. And we have our REST API, which is documented. You can also integrate with an SDK. And game developers can simply use our SDK and gather data from their users in a very simple way. So we try to make their life easier. And a lot of our users are early small game developers that use us as their first analytics tool. And we provide a way to see real-time results and also historical aggregates. So the question that we can ask is basically how much data do we process, right? And at the moment, these are the numbers on the last months. We are at peak at 165 million daily active users. And every month we see 1.7 billion users from mobile. Each user is usually a one mobile device. It can be something else than a mobile device, but mostly mobile devices. We track 25,000 games per day. And the total number of events that we process every day is around 19 billion, and the data is in JSON format. So this is basically an overview of the web tool will look like. You have this will be a studio overview. You see your games. You see the main key performance metrics per game. We call those KPIs. And this will be the dashboard overview where you will see results over time for your games, different metrics. And then we provide interactive dashboards. That means that we allow users to track a very specific user behavior and dig down like into the real small details about what their users are doing in the game. So we provide complex filtering and many different metrics, splits, and so on, right? And this is basically how the tool looks like. And this will be the filter, what we call the filter picker, where you can select complex configurations, so complex filters in order to see detailed behavior. And let's going into the technical requirements. So the question would be, what are the high-level technical requirements to provide a service like game analytics, right? So the first thing that you need is a responsive frontend. So these queries that request user behavior information, they need to be very responsive. You need the real time. So the users want to see information real time. So every game developer wants to see in the last hour how many users do you have that have done this specific action, right? So you need a streaming ingestion in real time. You need reliability, of course. The infrastructure needs to be running all the time. You need to keep cost low. Infrastructure cost is very important with such an amount of data, and flexibility for users. And another important thing is that all the metrics, or most of the metrics we provide, relate to the number of unique users. So you're always counting how many users do something. Simplifying the backend a lot, we can talk about three main components. One thing will be data collection. The other part is data annotation or enrichment, where we process data and annotate information. And then the last system is a real-time analytics system where we do aggregation and reporting. And the data goes through the system in what is called a streaming fashion. This will be an overview of how the data collection looks like. So we have all the SDKs running in devices, providing traffic through HTTPS to our REST API. And we collect this data, and simply we have a bunch of collectors running behind a load balancer. And what we do is store these events in a storage system, which in this case is S3. And this is a critical system because if this goes down, basically we are losing data. And the traffic on this API is quite high usually. So this will be some metrics from like 2-3 p.m. Close to our peak during the day. And yeah, these are the amount of, we are close to 100,000 requests per second in the data collection system. And the peak is something around 300,000 events per second. So we run different data collectors in an auto-scaling fashion. And these data collectors are stateless, and the only thing that they do is they receive a request, they process it by parsing, annotating, and so on, and then they directly buffer some of those events and write them to S3 in a file. So as you can imagine, like the Erlang VM is really good fit. It's a really good fit for this problem. It allows us to actually keep costs low. We could use any technology, obviously, because it's horizontally scalable. You can just keep adding servers. But Erlang really helps us keep this cost on check. And for the web server, we use a web server called Eli, which is not very popular compared with Cowboy, which is the normal choice. And we are happy with it. It fits the problem well, where we have and it was actually created by the former backend lead at Game Analytics. So we inherited this, the usage of this web server from them, and we are happy, and we keep using it. And for JSON parsing, we use Jiffy, just because of performance. And data collection is written in Erlang, and the type of instances we run is C5X largest, and we run about 40 to 60. And one thing I wanted to talk a little bit about is the infrastructure management and provisioning and so on. How do we provision our Erlang systems and ensuring like the 100% availability that you need. And we run everything on AWS. All infrastructure is in AWS. And when it comes to the DevOps practices, you want basically automation and repetitive builds. You want to be able to have your infrastructure as code. So every change you make is tracked in a repository. It's important to have secure secret storage, and the infrastructure you want it to be immutable. Among other things, yeah. And the technologies that we use are a combination of Terraform, Ansible, Packer, Travis, and we use Distillery and Relics to generate releases in Erlang and in Elixir. And we deploy mostly AMIs on EC2, not containers. This is an overview of how the provisioning looks like. Basically, when we want to provision, when we want to deploy a new system from code, we have a two-step process. The first thing we will do is create a Git tag in our GitHub repository, and that will trigger Travis CI, which will, of course, compile, run the tests, and build the release in case of attack. And that release will be pushed to GitHub releases, which is our artifact repository. And after this is done, it will trigger Packer, and Packer will use Ansible to fetch that release and provision the machine, which is an EMI in this case, an EC2 instance that will generate an EMI. So every time we create a Git tag from a service, it will end up automatically without just generating an EMI. And the second step would be that a developer, we will go and create a pull request in our main Terraform repository, specifying the new version number. And that will trigger a plan so we use a tool called Atlantis that integrates with Terraform, and that will generate a plan, and then we can apply the changes and automatically will deploy the new service. So it's just a two-step process, and we can roll back very easily by just changing the version number in case of need. So as I said, we deploy releases, only releases. And for a configuration secrets, we use Ansible Vault. And then we run all our Erlang and Elixir VMs under supervisor D, so that in case of a crash, they restart. Unlike with, what's the name? Hard, I think, is the system of the Erlang system. And we have some problems. Probably Magnus can extend on that later. And for logging, we use Papertrail. It's a system that provides a full text search, and we are more than happy with it. And all infrastructure is immutable, so we deploy an instance, and if we need to deploy a new one, if we need to change something, we will deploy a new one, even if that is a configuration. We don't use Erlang code upgrade for anything. And this configuration that we use is static. We don't, as I said, if we need to change a configuration, that requires redeployment of an instance or a service. We cannot change a configuration on the fly. But it's not an issue because we don't really find ourselves doing these changes at any point. It's very rare that we need to change a config in production. Yeah. So back to the data collection. For data collection, we actually use what is called a blue-green deployment to guarantee the availability. So what we do is we have two auto-scaling groups in AWS and two load balancers, and we can regulate the traffic with Route 53. So we can say send 20% of the traffic to blue and 80% to green, or 1% and 99%. And this is very flexible because we can even test in production. So we can spin up an instance, send 1% of the traffic to it and see what happens. And also we can deploy 50% on each load balancer in production. And we can compare two different releases, the performance, if we have made some optimizations, and really see what's going on. So it's pretty good approach for this. And we have a blog post on this topic. There will be a link in the last slide. And this is the data collectors over time. And our traffic, as you can see, is very predictable. During the day, we have the peak. At night, it's every single day pretty much the same pattern. So we go from 60 instances to 45. And yeah, coronavirus and lockdowns have increased, made the traffic increase by quite a lot, as you can expect. And for monitoring, we use Graphite and Grafana Cloud, and we instrument Erlang systems with a library called Statman that you can find on that link. And it was also a library created by the former backend team back in the day at Game Analytics. And we use that for application and beam metrics. And obviously, good Erlang instrumentation is critical to spot issues and be able to diagnose them. And yeah, that allows us to sleep well, having good metrics and good monitoring. And you'll always keep an eye on any dashboards, or so that you can spot problematic trends. And we use CloudWatch a lot as well for monitoring. So this is mostly about data collection. And the second service that I mentioned is data annotation. So once we receive all this data in an S3 bucket, we automatically it starts being processed by the annotation service. And the reason why we need this service is because the analytics system, which is the third service, it actually requires the normalized data for ingestion because it doesn't support joins. So we need to annotate the data and to then be able to filter. And this is required because we want to provide real-time analytics. So batch processing like Hadoop or Spark is not good. We use that as well for other reasons, but we need the streaming in order to be able to provide real-time results. And we use Kinesis for that. The annotation systems annotates information mostly related to the player's past, and also attribution, which is information related to where the player comes from that we get from different services. So this is a very high-level overview of the systems. It's an Erlang cluster, which is a master-slave architecture, and we'll read from our raw data bucket, which is where we place the data from collection, and then we'll annotate the data into the annotated bucket, and from there it goes to the third system. And the state is kept in DynamoDB, and we use Redis for caching. The master-slave architecture uses a library that is also developed by Game Analytics that is called JScheduler, that can be found in that link. And this is problematic for many reasons, and we are about to deploy to production like a masterless architecture. So we will use SQS to schedule the work and run the workers. So we'll remove the need for a master. And talking about the analytics service, this is what we used to have, which was a massive, complex Erlang system that used to will take the annotated data and process it in a streaming fashion. And it was a system that was, well, basically the annotated data bucket that you can see there is the one from the previous slide. And this streaming system was very ambitious for the time when real-time analytics were kind of in infancy. And it was developed not by us, by the previous team. And it was a really great Erlang system, I have to say. And it used a hyperlog log algorithm for calculating unique values. And it was actually quite fun to keep it running in production. But if fun is the right word to describe it with the traffic increase we were experiencing. But yeah, we just maintained it. And yeah, it used streaming data in memory and DynamoDB for historical data. And the thing is that the query latency was very fast. So that's what allowed the dashboards that we saw before to be so responsive, because you were fetching data from DynamoDB, which is very fast, and from memory, Erlang memory, which is also very fast. And the Hyperlog implementation is also open source and is written in Erlang, and you can find it in that link as well. And it was implemented by Game Analytics. So once we joined the company, at the time Magnus and me joined, there were many problems with the old system. The cost was not efficient enough with the amount of traffic we had. The reliability was an issue because it was a master-slave architecture, so that was a problem. It was very difficult to implement new features because it required complex coding. We lost the knowledge of the code base because the team left at the same time before we joined, so we didn't have that good knowledge on the code base. And it was also very limited in the filtering, so we only filter by one dimension. So we wanted to spend time delivering value for the customers and not implementing complex like streaming analytics systems. So we had to change technology, unfortunately. And yeah, the big data is Java, is a Java place, Java Gold. So we didn't change to Java, but we switched to a technology called Apache Druid. And I think Magnus will speak a little bit about this. I think he will start sharing, and we continue explaining about our usage of Druid. So I will stop.
That's right. Let's see if I can share my screen.
Now I think you should be able to.
There we are. Can you all see that? Right, yes. So we started using something called Apache Druid. So Apache Druid is a fast OLAP database, as they call it, which stands for Online Analytics Processing. So yeah, so what really got after that was that we can filter on multiple dimensions on our data, unlike the previous system. And we get real-time streaming ingestion of data. So yeah, it's well from when a game sends an event to when it actually ends up in the database, it's just a matter of minutes. And it's developed by a company called Imply. So this is what the picture looks like now. So we're still getting the data from this S3 bucket. And we have two kinds of ingestion here. We have real-time ingestion through Kinesis. And we also do a daily batch ingestion through EMR for a number of reasons. The data we get through Kinesis is ingested through hourly granularity, so you can see in which hour and the event occurred. That takes too much space to keep on indefinitely. So in this batch job, we reduce the granularity to daily granularity, which is, well, it's a lot smaller. We're able to keep more data that way. So Druid basically works like this. Instead of storing each event in a separate database row, it takes all the events that have the same value in a number of fields called dimensions and stores them in the single row. And here in the example on the slide here, we see all the data for a certain game where users installed the game on the 13th of January. They sent this event on the 1st of February. These are only users from the US using a certain Samsung model. and the event they're sending is complete game. So, so we see the metrics on the right-hand side, which are basically the sum of the values in those events. So we are just over 1,000 of these events, and from 39 unique users. So the unique users here are calculated through a hyperlog approximation. So we don't actually store the ID of every single user who sent this event. We just have this approximation of how many unique users there actually were. So usually we would just query by game ID and timestamp, and then Druid will sum up the metrics from all of these rows that match the game ID and timestamp we're querying for. As you saw in the diagram earlier, we have a query layer that's between our web frontend and Druid. And we do it for a number of reasons. First of all, we do it for access control. So we want users they should only be able to access data about their own games. So our query layer adds a filter that filters on the game ID before actually sending the query to Druid. And we also want to keep knowledge about how to implement various metrics in the single place. So the front end, it just makes a query to a named metric, such as unique users or revenue. And then the query layer translates that into a Druid query. And we also do some optimizations in the query layer. So we pre-compute a number of metrics for each day. So if a user wants to see those metrics, we can just go to DynamoDB. We don't actually need to go to Druid. We do some caching as well, and we do a data source selection. We actually ingest the data into Druid multiple times, some with more dimensions and some with fewer dimensions. So in the data source that has fewer dimensions, obviously you can't do that many different filtering options, but the queries are much faster. So that's something the query layer handles. So the query layer is implemented in Elixir. We are using a framework called Maru, which makes it easy to implement an HTTP API. It gives parsing and validation for both query string parameters and JSON request bodies. So we're running this in an auto-scaling group behind a load balancer. So we don't actually use the auto-scaling feature because load is pretty constant. So we just use it that we have two instances, and if one of them goes down for whatever reason, then the auto-scaling group would just spin up a new instance, and we have no downtime here. When we started developing this, there was no library for querying Druid from Elixir. So we wrote one, and we call it Panoramics. And you can see here the GitHub link, and also on HexPM. So it uses ecto-style macros to generate JSON queries for Druid from more or less idiomatic Elixir code. And for caching, we use a library called CacheX. So another feature that we recently developed is remote configurations. So if the game wants not only to get analytics from us, but they also want to be able to configure things in a game without having users update to a new version. So in this example on the slide here, we have a game that asks what is the current background color, and the system says the current background color is blue. And the developer can change that at any point in time. And this is similar in a way. It's Elixir and Maru. And the service stores the data in DynamoDB, and we also use CacheX to cache data. So if you have many users playing a single game, then we'll most likely only need to make one request to DynamoDB, because all the other requests from that game for the other users' devices will be just served from CacheX. And on top of this, we built a feature we call A/B testing. So here we see how a game developer would select a target audience for testing some different values for a certain configuration parameter. So, and the analytics side of it looks like this. So here we can see that we have a control group, and then we have 3 different variants called B, C, and D of users who get sent a different value for a certain configuration parameter. So in this screenshot here, we can see that variant C and D have a slightly higher revenue than the control group, while all the variants B, C, and D have slightly lower playtime. So A/B testing basically works like this. We have the user's devices send a request, including the user ID, and the A/B testing system. It looks up in DynamoDB. Both looks up the user ID to see which testing group the user has been assigned to, and also which value is supposed to return. So as you see here, one user gets the background color blue, and the other gets background color white, which is what we're testing in this case. So costs is obviously always interesting when doing cloud services. So we looked into the AWS cost for all this system, and we found that the biggest single cost here is the outbound network traffic for the data collection service. So even though the games are sending large amounts of data to us, the biggest cost is actually the outgoing response for the responses to those requests. So it's a bit counterintuitive. That's because EC2 charges for outbound traffic, does not charge for inbound traffic. So we set out to do something about this. The first thing we did was trimming some unnecessary HTTP headers in the responses. So we send this basic response status OK HTTP 200, and it turns out we sent a lot of headers that were not actually needed. So we get around 5 billion requests per day, and the cost for outgoing traffic is about 5 cents per gigabyte. So every byte counts here. So we remove those headers you see in red here, and this saves about $56 per day, or around $1,500 per month. So it turns out we can actually do save much more data by looking at the TLS handshakes. So at first we were using a TLS certificate from AWS Certificate Manager, and it has a fairly long chain, so we need to send 3 intermediate certificates along with every new connection. And so total length of those is 4,920 bytes. And we shopped around a bit, and then we bought a certificate from DigiCert instead. And with that, we only need to send 1 intermediate certificate for a total length of 2,767 bytes. And so there are 2 billion incoming connections, so 2 billion TLS handshake negotiations. So saving those 2,000 bytes from the handshake, it saves us around $200 per day. So that was a worthwhile exercise. Yeah, and here are some links to what we've done. It's a blog post about how we reduced the data transfer cost. It was featured as a guest blog post on the AWS blog. And we also did a case study for Imply, the company that's developing Druid, and we also did a webinar for them. Was it last month, I think? And we also have a blog post on our own blog. It goes into more details how we do the blue and green developments, blue and green deployments. So those are all linked right there. And yes, we're hiring. We got a link right there. So if you want to work with us, you're very welcome. Yeah. Thank you all. Do you have any questions?
Could I suggest we put the questions in the chat, and then Martin will pick someone you can, will pick the speakers, and then you can just unmute yourself and ask the questions. Yeah, so we have a question from Edison Jap. If you want to unmute yourself or...
Okay, yeah. So I have a question on like the transport protocol. You guys mentioned you were using JSON for everything. So I was just wondering, like, would something like say protobuf save you like a lot more bytes and therefore cost?
Not that much actually, because we're charged for outbound data, not for inbound data. So it's the difference. We wouldn't actually pay very much less, and we also want to keep the format as JSON because we want this to be easy to implement. So even if users, well, we have SDKs for many platforms, but we also want users to be able to just implement our REST interface and get it working. So that's why we sort of stick to JSON as a lowest common denominator.
Yeah, and also you want a format that is common across big data systems, so JSON is one of them. And our Druid supports JSON, no problem, so everything works well in that regard.
Okay, that's pretty clear. Thanks, guys.
Yeah, I think we have an interesting question from Wiebe Martin.
Hi there. Yeah, I was wondering at the beginning you told us that for the analytics part you were using the web server Ellie, and you already noted there that you used Ellie rather than Cowboy because Ellie was something that was developed in-house by the earlier team. And I was wondering what are the advantages and possibly disadvantages of using Ellie over Cowboy, and why did you stick with Ellie for the time being?
Well, the first reason is effort, right? Even if Cowboy was a bit better, the only thing that we will save is cost. And the cost of development, I don't think will pay for the cost. And that even if Cowboy was more efficient, right? But we doubt that Cowboy will be more efficient. I think that Ellie was developed for this particular use case where you have so many connections, and maybe Cowboy might be better in other use cases. I don't know. We haven't profiled both. We don't. Also, personally, I don't know enough about the code base of Ellie and Cowboy to have a strong opinion on that. If you go to the Ellie GitHub repository, there are some notes there on design choices for Ellie, so that might be interesting to read. But the first answer to the question is the matter of effort. So we need to decide what to work on, and this is probably not worth it, even if Cowboy was a better choice. And Ellie is still actively maintained by a new team, so we keep getting updates. It's fine in that regard.
Yeah, there has been some requests for the slides, and they will be uploaded to the Meetup group. So Mustafa got a question about inbound
There's
data.
one from John. There's one from John.
Oh yeah. So John has a question about the cost savings. You wanted to ask yourself, John?
Hello.
Yeah.
I just wanted to know what the biggest cost, either money or time-wise, for an individual request from a game to your stack was.
So you are talking about a request from the web tool where they see aggregated data.
I was mostly interested in inbound requests. Like you've obviously profiled that SSL was expensive and that your headers were expensive. So I was just wondering what was the biggest cost within your stack after that?
After that, it will be probably the data processing on Druid. So Druid will be the most expensive part of the stack. Running the Druid cluster is a massive cluster. Yeah, so really, really big. Like we use i3 8x large instances, and we have 15 of them for just the data gathering. So it's quite an expensive system. I don't know if Magnus has other thoughts, but I think that will be my answer.
Yeah, that's pretty much it. Druid is the big thing here. And as for the HTTP requests, HTTP responses themselves, after those optimizations, the TLS handshakes are still the biggest outgoing data. So we're trying to increase the connection keep alive to reduce the number of TLS negotiations and so on. That's there are some more details in the blog post about that.
Yeah, and one thing interesting, I think, is that we reuse the same load balancer for all this. So A/B testing remote configs, any connection from an incoming device will go through the same load balancer so that we can reuse as many connections as possible, because connection is the most expensive part of the data outbound.
I need to unmute myself before I can speak. So is the inbound data on collectors buffered in memory, or is it on disk? Asked by Mustafa.
Yeah, it's buffered in memory before we write it to S3.
Cool. And we have a question from Luke here, why not use UDP instead of TCP?
Well, yeah, that's because we need the games need to be sure that the data actually arrived to our system. So if they don't get the confirmation from the server, they will try send the events until they actually get there. So that's why HTTP makes sense in terms of semantics. And yeah, even if we were able to develop some kind of custom protocol, we still want to cater to cater to the lowest common denominator. We want everyone to be able to use our SDK, our REST API, either through the SDK or without an SDK. So that's why we HTTP and JSON is a tried and true thing. That's what we offer.
Yeah. So any other questions? Nope. Well, thank you very much for an excellent talk. Interesting. And the slides will be up on the Meetup site afterwards.
Thanks for listening.
Yeah, thanks for having us.
Yeah. So is Evadne ready?
Hello. Yes, I'm ready.
Yep.
And I shall share my screen.
Mm-hmm. Yeah, so Evadne is local to London, and she's often given presentations at these meetups. I think it's the 5th time I see Evadne give a talk, so it's always interesting. So this time will be about macros, as I understand it, because why write code when you can make code that writes more code?
Yeah, sure. So I guess today's session will be quite informal. I suppose that people want some entertainment. Hopefully, I'll be able to provide that entertainment. So why macros? The answer is macros are good because they allow you to write less code. And sometimes they allow you to write better code. By using macros, you can, for example, increase your expressive power by defining your own operators, so you don't have to write multiple lines of code to do simple things that you can do in other languages. You can use macros to improve the runtime performance of your application, for example, by pre-compiling content into modules, so they're loaded into memory directly. You don't have to hit the disk to read the same thing over and over again. You can use macros to do code generation. So you can basically simplify code, although obviously Robert Verding has a different opinion regarding usage of DSLs. He said, if you want to use a DSL, use a DSL. Don't make Elixir into a DSL. So to each their own. You can also use macros to do illegal things, such as introduce object-oriented programming using Elixir. There's a lightning talk at ElixirConf a few years ago on Elixir object-oriented programming, but I shall not play that talk now because it's too funny. Okay, so the core concept regarding macros, I think, can be illustrated by looking at this tool. This is called AST Ninja, which is a tool presented earlier at an ElixirConf session by a fellow speaker. He's got a talk called The Elixir Parser Under the Microscope. And that talk introduced this tool called AST Ninja. So what exactly is AST in Elixir? It's called the abstract syntax tree. When you program Elixir, somebody's in the chat. Okay. Oh dear. Somebody posted OOP link. No, please don't. Don't post it, man. So so when you write Elixir, usually you write something like, okay, def module foo do. Then you can say def bar do. But this is basically a big string to Elixir. The content has to be parsed, and internally in Elixir, the code is represented as a data structure. Again, the design principle of Elixir uses the concept of data over code a lot. So you will see everywhere in Elixir, where possible, the design decisions are usually made to err on the favor of exposing stable, clear data structures. So you can see the def module is internally interpreted as a very big tuple. Very big tuple with 3 things. So first def module, and then the metadata, and then the content. So a simple def bar, actually, I can do it like this. A simple def bar is interpreted as a def and a metadata, and then stuff. So this is the buzz line. So if I were to do this, it'll be clearer. See, so def high, and then do block foo and bar. So by using macros, you can essentially manipulate the AST, generate the AST fragments, and do code generation this way. So you might have seen in macros, sometimes you use this quote. What is quote? So quote is essentially a way to generate fragments. I shall demonstrate. So foo, atom, quote foo, quote do, foo, still an atom. Foo bar, this is an undefined function. Quote do, foo bar, this is the call. In this case, you can quote it. So the quote thing always returns to you something you can insert into the rest of your AST. And this is the foundation of macros. All right. So I think the best way to do it will be to look at another project called Operator. Headed by Brooklyn and her gang. The Operator project is a project that allows you to define Elixir operators. So what exactly are operators? Well, this. If you do 1 + 2, this is the infix operator here. In Elixir, what exactly does this mean? Well, we'll do 1 + 2, and you get actually it's a code to a function called plus. So in Elixir, special operators are special functions with special names, and these names contain symbols. And in the Elixir compiler, the symbols are hard-coded. There's a limited number of them. So you can't say, so you can do, for example, 1 tilde bracket 2. This is recognized, but you can't do this. This is not even recognized. And you get a syntax error. So there's a limited number of operators. But anyway, operators can be defined this way. So usually when you define an operator, you will do this. So def okay, actually A, B, do. Hopefully it works, but it doesn't work, unfortunately. I have forgotten how to do it, but no worry. I have prepared a module. Yeah, thank you. I have prepared a module. So let's see. The operator project allows you to say something like add operator, and then define operator, and then say, okay, I want to call it arrow, but actually it does on arrow AB. So how does it do that? Well, when you use the operator, when you use a module like this, Elixir actually basically calls the modules using macro within a module, like this. In each module, if you define the macro called using, then this macro is called whenever in other modules you use use and then pass the name of your module. So as you can see, by doing this, instead of asking other developers who use your module to write many lines of code, you can just simplify it and say, okay, use the word use module name. Why would you want to do that, you may ask? The answer is because usually when you adopt an external module that contains macros, you want to also use these macros, and sometimes macros call functions, and you don't want to manually import or do the requires. You want to just use a single line, and this also encapsulates the setup behavior. So that's why you use the using macro. As you can see, in the using macro, you emit a quoted fragment where you say basically import kernel, require import, register attribute, etc., etc. So let's do it this way. So right now I have an empty module, even though I have done this. Recompile. And now you can see the definition for the function is now in place. And my original function is here. All right. So that's how you generate macros. So there's another way to use macros. For example, you want to for example, add something that changes whenever you recompile the file. You can do something like this. F macro now do quote to quote now. I think this should do. Okay. It's UGC. So okay, invalid quoted expression. In this case, you can see not everything can be included into your macro immediately, but you can obviously escape. I believe it's like this. So by using escape, you can now introduce a value. So let's say in the operator thing, I will also do require macro time dot datetime. And I will say arrow AB datetime dot no, like this. Not sure what's going on with the operator, but let's see. Recompile time operator dot arrow 1 2. Now you can see the date time is here, but let's say I change the operator file, and you can see the value has changed because as recompilation has happened, the included value of the macro is changed. So you can essentially use this to introduce some kind of annotation on your files if necessary. And just to review, by using unquote, you can bring previously quoted values that you generate outside of the macro body into the macro, and then use it in other places in your macro if you wish to. So another reason why you want to use macros is basically to simplify code, or for example, to leverage the characteristics of code generation in Elixir. Because in Elixir, pattern matching is a big thing. So I will show you an example. So let's say you have a problem where you have a function, and you want to say, okay, if you get foo bar, then return buzz, and if you do foo buzz, then so in Elixir, this block, basically you got a function head and you have additional clauses. So when you call foo, depending on the argument, whether it's bar or buzz, the Elixir basically uses pattern matching to give you the right results. So why is this important? Because this pattern is usually used whenever you have macros. So I'll give you an example. Let's say you have defined a DSL. You say, I want to define some kind of IP firewall rule. So let's say first I use a use macro to bring in whatever necessary to actually build the module. And then I start writing my rules. So I can say, I want to reject everything that's in this CIDR. I want to reject everything that's within this CIDR. I want to do whatever. So in this case, each line here, reject preset and whatever, these are macros defined by using the builder, eventually results in function calls is being generated. So if I were to do this, say recompile, this is my little IEX shortcut to decompile and print the module, but I'll show that later. You can see the reject here, 10.008 has been first changed to something with a function clause, basically with a condition. It's not here for whatever reason, except do this. No. Yeah, the decompiler is not very good. But internally, what it's doing is these macros like reject, accept, and handle whatever macro, they're all contributing to generating quoted fragments, and these quoted fragments are then paused in compilation paths to generate the module. Okay. All right. So by basically using macros, you can simplify your code and allow usage of DSL. I think it's better for us to look deeper into Sean, but first of all, we need to look at what our printer is doing. So I essentially stolen this decompilation module from GitHub. But maybe this means that this will work. I hope. Okay, it doesn't work. So let's look at the Sean builder, which is in a library that's built around allowing rules to be defined using a DSL. Essentially, you can say, I want to accept all the URIs that match this pattern where the host is example.com, reject everything. As an example, accept, or I want to handle the URIs with a custom function, whatever. So in this case, you can always see first you bring in the logic, which will give you compile time logic by usually using a use macro, because this allows you to just put one line in the target module. and then you start adding function clauses, accept, reject, handle, whatever. And then somehow the before compile macro is called when the function when the module is to be compiled, because when you use, the before compile attribute will be modified essentially, and you append this. So this tells the Elixir compiler, before the module is compiled, please call the before compile macro in this module. And in this before compile module, you can walk the module attributes, walk the rules, and build the code that make up these rules. Well, I think a better way to do it would be to, let's say, see if I can add some logging statements here. So, oh. Yes, I could do this, could I? Okay. So you can see the before compile macro is called on the environment, which contains a file here, context module, macro time shown. Okay. So this works very similarly to the Phoenix router module, where you define routes and you just say route. And at the end of it, the Phoenix router contains a before compile macro, which, well, looks at all the attributes we have previously accumulated, and then emits the right function heads and pattern matching stuff. So your router works. Okay. Anyway, so when you do code generation with macros, you essentially have multiple options. The first option is, when I define a macro, like this, I can just say, okay, I emit a code immediately. So this is the first way to do it. When the macro is called, immediately the code fragments immediately. And this is usually sufficient if your usage is not very complicated. But in certain cases, you don't want to do it. Okay, in certain cases, you don't want to do it. The reason is maybe the rules need to be reordered in a certain way. For example, if you mix the acceptance rules, so you written a module where all the accepts are written first and all the rejects are written second, and then all the handles are written, you might want to reorder them in a way that actually makes sense. In which case, you can not emit the code directly, but you can leverage the fact that essentially macros are essentially run during compilation, and you can run arbitrary code, including appending stuff into a module attribute. So in this particular case for Sean, I'm actually doing something called put quoted rule. So what is it? It's a little quote. It's a little quote that actually does not contain code, but contains code that modifies the module attribute. Okay, so this add thing in Elixir, what is this? This actually means modify the module attribute named rules with this new value, which is a list with a prepended item, and the rest of the body comes from the existing value in the module attribute. So by doing this, essentially, you can accumulate content into a module attribute. Yeah, so first, grab the rule, put quoted rule here. So again, what is put quoted rule? Again, you can see in this macro, you've got the target, which is the value, but the value isn't used directly. You can pre-process the value, like rule accept target. So what is it? I'll show you. Rule accept. It's this. So this is an internal data structure. essentially within the macro, you can first prepare the value passed into the macro into some kind of intermediate data structure, and then quote it, and then emit a quoted fragment that prepends that thing onto a list. And then, because your users would have called the use function, so your use thing would have imported everything and then instructed Elixir to call your before compile macro before the module is compiled. Then during that final compilation session, you can then grab the rules, reverse them, and build. And you can reorder them here if you wish to, if there is any need. And since this basically runs last, you can basically have a lot of safety. So you can have shenanigans like this, but that's something else. Okay. So let's look at another example. This time, let's look at Phoenix. Any version of Phoenix will do, but in this case, let's look at, I think this is Phoenix 1.4, yeah, 1.4.16. I think there's a new version out, but let's look at this version, Phoenix templates. So have you ever wondered what exactly is the render function in Phoenix? The answer is the render function in Phoenix is just a trampoline. It calls a render template, and the render template functions are generated by macro at compile time. So before a template module in your application is compiled, actually all the templates that can be found by this module are looked at. So again, see in this before compile macro, you don't necessarily the Phoenix authors do not immediately emit the quoted code, but instead they do some preparation work first. So in this case, okay, find out where the templates are, and then compile all of them. So this has the added benefit of if you have made an error in creating the templates, then the compilation will halt here. So instead of a runtime error, you get a compile time error, which is quite good because it means that you can always catch these things. Oh yeah. Okay. So in this case, the compile function returns the names and codes, and you can see how code generation works here. Unquote codes and do a catch-all clause. So what's in the code? It's basically in the code you have render template and then the names like show.html and then something, and then within here, this is the Elixir version of your compiled template. That's in the code part. So essentially, your templates are compiled like that in the code section, and then you always add a catch-all clause to catch everything else. So if there is no match in pattern matching, then this catch-all clause is called. Again, macros used by code generation are usually paired with this kind of paradigm, and you will see this paradigm over and over again. Okay. So, okay, back to Sean. In the case of Sean, in code generation, we do something similar, but in building, we essentially return a list, and here we have a bunch of rules. But so first we got headers, and then we got rules, and we got fallbacks, essentially catch-all clauses. So in the header, obviously grab the address stuff, so EC4, EC6, and so on. And here we have the dispatcher. What the dispatcher obviously verify IP. If the IP is v4, then call verify IP v4. Otherwise call IPv6 verification. Otherwise reject. And then for each rule, build the stuff that's required, and then build the fallbacks. And depending on whether certain rules have been defined, you can do different kinds of fallbacks. And here, this is basically the meat. Like if there's a URI rule, then this is how you name it, this is how you pattern it, and so on and so on and so on. So yeah, that's how code generation usually works. Right. So, okay. Elixir OOP has been shown, so I don't have to link to it again. But I suggest not viewing that if in the morning, only view it in the afternoon. All right. One last thing is, you don't necessarily have to do code generation this way. Why? Because sometimes you want to have the intermediate versions available for use. For example, if I were to say I want to look at some kind of service SDK, then I would say depth, and then I do something like this. And in these cases, the developer may want to access the intermediate versions, or you just don't want to incur a lot of machine time on pre-computing these things. In these cases, you will basically generate the Elixir files ahead of time and then distribute these Elixir files in a distributable package. An example you can look at is called AWS CodeGen, code generator for AWS clients in Elixir. So this thing essentially makes Elixir files like this. So it's got a template here. See, it's got a template, which is an embedded Elixir template that generates an Elixir file. So def module and then module name documentation string, and then for each action, generate action and generate a spec as well. It doesn't fuss around with AST, it just generates an Elixir file for in each invocation. And the end result is that you then take the results of the generation and plug these files into a library that uses them. So essentially you distribute these files. And well, the benefit is that if you want to find out what's going on in a particular service, how does that service choose? You can just look at the file, and well, at the head of the file, you can see when do not edit is auto-generated. But it doesn't matter, because in this case, it's actually a superior solution to macro